The lab, titled CORS Vulnerability with Basic Origin Reflection, is part of the prestigious Portswigger's Web Security Academy. In this virtual realm, we'll be facing off against an insecure CORS configuration, a dangerous oversight that trusts all origins, allowing unauthorized access to valuable resources. Let's access the lab. I have added the URL to the scope and hidden out-of-scope items. The browser used to access the lab comes with Burp Suite, as the victim uses Google Chrome. It's recommended for us to use either Burp's browser or Google Chrome to view the stored exploit before delivering it to the victim. We can now log in using the provided username, wiener, and the password, Peter. And now, we can see the API key for the wiener user, which is in the response of the GET request to the account details. Alright, folks, let's get this right. It's time to send the request to the repeater and have some fun playing around with those request headers, such as referrer and origin. Removing the ID parameter from the referrer request header doesn't seem to affect the response. Now, let's add something to the origin request header, like https://test.test. And guess what? It's reflected in the access control allow origin response header. These headers state that access is allowed from the requesting domain, https://test.test, and that cross-origin requests can include cookies, access control allow credentials, true. So, they'll be processed in session. Here's the catch. Since the application reflects arbitrary origins in the access control allow origin header, it means any domain can access resources from the vulnerable domain. If the response contains any sensitive information, such as an API key or CSRF token, like the one for the GET request to account details, we can retrieve this by implementing the following script on our website, which acts as the exploit server. Alright, folks, let's move on to the exploit server. The JavaScript in the body initializes the request, specifying the HTTP method as GET. It sends the request to our vulnerable website at the account details page and sets it to be asynchronous, true. The REQ listener function serves as the callback mentioned in line 2. Once the response from our vulnerable website, containing the API key, arrives, this function gets triggered. Within REQ listener, this line redirects the location to a new URL, including this response text, the data from the vulnerable site. This leads the user's browser to our exploit server. The specified URL ending with exploit holds our payload, which will be delivered to the victim later. Finally, we redirect the user's browser to our exploit server at log with the sensitive data as a query parameter, key. We can now store and view the exploit on the browser, which comes with Burp Suite. We see a request to our exploit server at the log path, and the API key of the wiener user has been included in the value of the key parameter. We can copy the value of the key parameter and make it more readable with the decoder that comes with Burp Suite. We will decode it as URL. Now, we can compare the API key in the decoded format with the API key of the wiener user on the vulnerable website, and guess what? They actually match. We can see the request to the exploit path from our IP address at the bottom of the access log. And now, we're ready to deliver the exploit to the victim. Now, let's check the requests to the exploit and logs paths of our exploit server. Here, we can observe that the API key for the administrator user has been included. So, we'll proceed to decode it just like before. We can then submit the API key as the solution, and voila! The lab is officially completed.